All right.
Hey, we learned this in algebra.
Good, you did. So it's kind of a review. All right. Anyways, all right. So today we're gonna start section 2.3, which has to do with long division and synthetic division. All right. So here's the reason why we're going to be using long division and synthetic division. On section 2.2, with formulas of higher degree, we learned about the leading coefficient test, and we learned to find the zeros and its multiplicity to come up with a sketch. Okay. Last lesson, you were using polynomials that were pretty easy to factor out, or in other words, pretty easy to find the zeros of. Now we're going to be dealing with polynomials that are not so easy to factor out. Okay, so I'm going to be using long division and synthetic division to help you factor out polynomials of higher degree. Okay. Anyway, so first, before we actually get to finding the zeros, I need you to practice dividing. Okay. Now, like I said, this has been taught to you before, so this is just a little refresher for you. Okay. So I gave you an example there for you if you want to look over it, and I also gave you the steps, but I'll just go ahead and show you one example, and then I want you to try it on your own. All right. So first of all, you need to be familiar with the words quotient, dividend, and divisor. Okay. Which one is your dividend? This right here with the higher degree, that's your dividend, and that's what goes inside the division sign.
Division box.
The division.
I like to call it a reverse fraction.
Okay, sure, Emmanuel, you can call it that. Okay, so that's your dividend. And what's your divisor in this case? This is going to be your divisor. So this is your dividend. This is your divisor. And it goes out here. Okay. All right. When you are doing long division, okay, you're only going to look at the leading term. So in this case, the x squared and the x. You're going to ask yourself, x squared divided by x, okay? Or the way I like to ask my question is, x times what would give you the same thing as x squared? X. So then you do x times x, which is x squared, and x times 7, which is 7x. If you remember long division, you must subtract. X squared minus x squared cancels out. It must cancel out. If it does not cancel out, you're doing something wrong. Okay? Now you have a negative x minus 7x. That becomes negative 8x. You're going to drop down the negative 56. And you repeat the process. X times what would give you negative 8x? Well, times the negative 8. Negative 8 times x is negative 8x. Negative 8 times positive 7 gives you negative 56. You're going to subtract. You're going to then notice that this cancels out, and negative 56 minus negative 56 is 0. That means that this is your remainder. Okay, you have a remainder of 0. And your quotient is x minus a. Okay? Now, I'm going to get a little bit ahead of myself and tell you really what we're going to be using division for. If I just ask you to divide, you'll be done. Your answer will be x minus a, correct? It will be your quotient. We're going to be using division to factor things out. In other words, I gave you something easy. You should have figured out that x squared minus x minus 56 is the same thing as saying x plus 7 times x minus 8. Do you guys agree?
Yes.
Okay. That's how we're going to be using division. Okay. And from there, we could set it equal to 0, correct? And then you find out that the zeros are what? Negative 7 and positive 8. And then we can come up with a sketch, correct? That's what we're going to go in the long run. Okay, but for now, I want you to practice dividing number 2, 3, 4, 5, I think, and 6. I give you a lot of examples for you to practice. So practice your long division, and then press play one more time. Okay, I want to bring your attention to number 3. So you'll notice that after you do the division, you're going to get a remainder. So when you're actually writing your answer, that means that your answer is 2x minus 3 plus your remainder over your divisor, which is x minus 1. Okay? So you put your remainder over your divisor and you're adding it. should be the divisor.
You messed up again.
I'm just such a terrible person. God. Anyways, alright, so you put your remainder over the divisor, okay, and you're adding it to your quotient, okay? And remember, your quotient is your result. Okay? Okay, check your answers. So let me kind of scroll back. So here is the pauses needed. Here's the answers for the first two. So it should be x minus 3. Pauses needed. Here's the answer for number 3 and number 4. And here's the answer for number 5 and number 6. Notice that it should be this plus that. Just want to make sure. Jack, if you're watching this video. Anyways, alright, so now we're going to talk about synthetic division. In my opinion, synthetic division is way better, a lot easier. However, okay, I want to bring your attention to this. Synthetic division can only be used when you're dividing by linear divisors. So that means that whatever you're dividing by, your divisor can only be of the highest degree of 1. Okay? It can only be degree 1 when your divisor. If your divisor is greater than 1, the degree is greater than 1, I'm sorry, you're going to have to do long division. There's no way around it. Okay? So, I gave you the steps to try, but I'm going to go ahead and just show you an example. So, with synthetic division, rather than you doing your division symbol upright, you're going to do it upside down. So, like that. Okay? Now, your divisor still goes on the outside, but you're not going to have any variables this time. On the outside, you're going to set your divisor equal to 0 and solve for x. So x plus 2 equal to 0. That means that x equals to negative 2. Negative 2 would be the value that goes on the outside. It don't matter, honestly. Okay? And on the inside, you're going to keep the coefficients of every single term in order from highest degree to lowest degree. I'm sorry, to constant in this case, correct? Alright, so the highest degree is x squared, so the coefficient in front of it is 1. And then the next degree would be x to the first power, and the coefficient is 8. And lastly, you have a constant, which is 12, so we put our constant there. Okay? So some of you guys have done this, some of you guys have not. So the first step is you take the very first number, and you're going to drop it. Just bring it down. Okay? Alright, so then you bring it down just as it is, and then you're going to take that value and multiply it by your divisor. So 1 times negative 2 is, and you put the results on the next column, okay? Alright, so then you're just going to add the results. What's 8 plus negative 2? 6. You write your result down. Then you repeat the process. 6 times negative 2 is negative 12. 12 plus negative 12 is 0. Okay? So here's what this means. Now we're going to bring our variables back. Notice that the highest degree that we started with on your dividend was to the second power. That means you're going to start bringing back variables, but with 1 degree less than that. So instead of starting with x squared, you're going to start with x. So that means that you have 1x plus 6. Correct? Or in other words, you have x plus 6 as your quotient.
Whoa. Oh my goodness.
Okay? If you wanted to write this as linear factors, what do I mean by linear factors? That means I want you to factor it out. In other words, we could have said that this was x plus 2 times x plus 6. Correct? That would give you the x squared plus 8x plus 12. Correct? And then if I wanted you to find the zeros, you can go further and set them equal to 0, etc., etc. Correct? Alright. I want to bring your attention to number 10 before I pause the video. Go to number 10. We're going to try it. But one of the things I want you to notice is that the highest degree is 3. Then you have a second power. But then you don't have a first power. You must account for it. Okay? You must use placeholders. Use placeholder when missing powers. So here's what I mean by a placeholder, okay? So I'm going to do the division. The highest degree is 3 and the coefficient is 1. then the square, and then we have a 2. But you don't have an x to the first power, so you're going to put a placeholder of 0. Okay, that's what I mean by a placeholder. And then 32. So third power, second power, first power, no power. Correct? If you do not put that 0 in, your division will come out wrong. Okay? So now, what goes on the outside? What's my divisor in this case? -4. So you're going to bring down the 1. 1 times -4 is -4. 2 plus -4 is -2. -2 times -4 is 8. Bring down 8. 8 times -4 is -32. So what's your quotient? X squared minus 2x plus 8. That's your quotient, correct? Can you tell me what would be this equation as a product of linear factors? As a product of linear factors. So what are, first of all, what's product? Multiplication. Okay, linear means what?
A line.
Right? And if we're talking about equations in this case, it's lines, it's factors of to the first power. Okay, so do you agree that this factor right here has a first power? X plus 4. And if I want it as a product of linear factors, what must you do with this quadratic? Factor it out. Okay? So does this factor out? To be what? Does it factor out?
No.
Does not factor out, does it? Because if you do x plus 4, I'm sorry, x minus 4, x plus 2, you match this, but you will get a -8, correct? It's not factorable, okay? So could you factor this out? No. So if you wanted to find the zeros, what would you do? You can complete the square, or you can use a quadratic formula, etc., etc., correct? Okay, so I want you to practice using synthetic division. For the rest, I gave you, I think, 4 or 5 problems for you to practice now. And then come back and check the answers. Okay, check your answers. Pause is needed. So here's number 7 and 8. And actually, so all of them, check your quotients. So remember, at this point, you're only dividing, so all I'm really looking for is the quotient. If I ask you to divide, all I'm looking for is the quotient, okay? Here is number 11 and 12. Here we go. Alright, so, to help you factor, okay? In example number 11, you had x to the third power minus 3x minus 2, and you divided it by x plus 1, and you got what answer for 11? X squared minus x minus 2, okay? Do you think that could factor in even more? What would it factor to?
X minus 2, x plus 1.
Good. So in other words, would you be okay with me saying that the product, listen to the vocabulary, the product of linear factors would be x plus 1 times x minus 2 times x plus 1, correct? That will be a product, because they're being multiplied, of linear factors. Linear because they're all power of 1, correct? And we can call this f of x, right? That's the function that was given originally, okay? So, could you have factored this out if I didn't give you that this was one of the factors at the moment? Could you? So if I didn't give you this, if I only gave you x to the third power minus 3x minus 2, could you have factored that out on your own? How?
The box method.
The box method only works for power of 2. This is power of 3. How would you have done this? You couldn't. Okay, you couldn't. Okay, so at this point, if I give you a polynomial of higher degree and I give you a factor, then you can use what to help you factor it out? Synthetic division or long division, and then that can help you bring down, because here's what happened. We did the division because now I gave you that this one was one of the factors. And then that brought it down to a quadratic. From there, can you factor it out? Yes. Okay? So that's how we're going to be using synthetic division to help us factor things out. Okay? So let's look at, for example, Oh, I had a space for all that. Whatever. Sorry. All right, let's look at 13. Okay? 13, you said. You have this polynomial right here. I want you to factor it out, and I am letting you know that x plus 1 is one of the factors. Okay? So what would you do? We can do synthetic division. So that means that we would have 1, negative 1, negative 5, negative 3, and your divisor would be negative 1, correct? Bring the 1 down, so this becomes negative 1. This is negative 2, that becomes positive 2. Negative 3, this becomes positive 3. Alright, in order for this to work, your remainder must be 0. Must be 0. If your remainder is not 0, what does that mean about that given factor? Is it actually a factor of it? No. So let's say if I told you that x plus 2, if I ask you, is x plus 2 a factor? You can use division, and then if your remainder is not 0, then you would say that it's not, correct? Okay, but in this question itself, I am telling you that it is a factor, okay? And since I am telling you that it is a factor, your remainder should be 0. If you do not get a remainder of 0, that means you made a mistake during your synthetic division process, okay? So, now, how does this help us? Well, now we know that it's x plus 1 times what? What was your quotient? X squared minus 2x minus 3. Now that you have a quadratic, could you factor that out? Well, let's talk about it. Minus 3 and plus 1. Half. This is called the product of linear factors. And if I wanted to take this a step further, could you come up with a sketch of this? Yes, we can. What's the end behavior of the given polynomial? False left, right is right. Plot your zeros. What are your zeros? Negative 1 and positive 3. So somewhere along there. Negative 1 has a multiplicity of, which means that it touches or bounces, whatever. So when you get there, you're going to turn back down. Then you got to turn at some point, come up, and cross, and match your behavior. All right. Do you see now how we're going to be using what we learned today to continue to do what we did last time? Okay. So I want you to try 14, and I want you to come up with a sketch as well. Okay. All right. Check your answer. Pause the video as needed. Okay. The last thing we're going to talk about is something called the rational zero test. Okay. You will use the rational zero test when I give you a polynomial. For example, look at the question number 15. I just gave you the polynomial. I gave you no factor. I gave you no information whatsoever. And I still want you to factor this thing out. Okay? So when I don't give you a factor, there's not really a way that you can use synthetic division because you don't have a factor. It is going to be your job to find possible factors. And the way to do that is to use the rational zero test. Okay? So here's what the rational zero test says. You're going to have a polynomial. Okay? And you're going to have a leading coefficient. And you're going to have a constant. Okay? What you're going to do, and I'm going to basically summarize everything this says into here. And this is a key word. It says possible. So that means that these are not actual zeros. These are possibilities. Okay? Possible rational zeros is the ratio of the factors of your constant divided by the factors of your leading coefficient. That only gives you your possibilities. Does not mean that there are actual zeros. I repeat, that does not mean that there are actual zeros. Okay? So, here's how it works. If you use a rational zero test, and you can find out at least one factor, could you then use synthetic division to do the rest? You could. So here's what we're going to do. Look at 15. It says, to find your possibilities, so your possible rational zeros, it says that you're going to take the factors of your constant. Your constant is 3. So what are the factors of 3? 3 and 1. Would you also agree that you could say negative 1 times negative 3? So wouldn't it be plus or minus 1 or plus or minus 3? Okay, good. Look at your leading coefficient. It is 2. What are the factors of 2? Plus or minus 1, plus or minus 2. So here's all of your possible rational zeros. You ready? What's 1 divided by 1? Plus or minus 1. What's 1 divided by 2? 1/2. Plus or minus 1/2. What's 3 divided by 1? 3. And 3 divided by 2. These are all your possibilities. Is that even, how many zeros are we looking to get? 3. So it obviously makes sense that all of this cannot be answers, correct? So these are possibilities. So here's what you're going to do. Once you find your possibilities, you need to figure out which ones actually give you a 0. How do you think I could do that? You would plug them in. This is where the calculator is going to come into play, okay? This will be on the calculator part of the test and your quiz, which is next time, by the way. But you must show work, because I am very aware that you can just type this into y equals and find all the zeros with the second trace calculate zeros. Okay, you're going to have to use actually show your work in order to get credit. So here's what I'm going to do. One of the functions that really come in handy is, remember back in the first semester I taught you how to store values? And say, you can do this, f of negative 1, f of 1, f of negative 1/2, f of 1/2, f of negative 3, f of 3, f of 3/2, and f of negative 3/2, correct? We're trying to figure out which one of those would actually give a 0. Okay, so here's what you're going to do. You're simply going to go one by one. So you're going to say negative 1 on your calculator, and you're going to store it on x. So STOX, enter. Okay, so now you can just type the equation. So 2x to the third power plus 3x squared minus 8x plus 3, hit enter. I got 12. So it's negative 1 a 0? No, it's not. So here's what you can do now. Instead of retyping everything, if you hit 1 STOX, now x is 1. If you go with your calculator with the arrow, you go up twice and highlight the polynomial and hit enter, it retypes it for you. So you don't have to type it all again. Then hit enter. Oh, would you look at that? That is a 0. Okay? Now pause. Because you already found a 0, do you need to go finding everything else out? Do you need to continue to find all the other values? You don't have to. You could if you wanted to, but now you know one of them. Could I use synthetic division now? Yes, I can, because now I can say 2, and then the 3, and then the negative 8, and then 3. And on the outside, what would you put? 1. So I'll bring that. That's 2 times 1, which is 2. That's 5. 5 times 1 is 5. That's going to be negative 3. And negative 3 times 1 is negative 3. That's 0. Okay? Which means then that you have x minus 1, correct, times 2x squared plus 5x minus 3. You guys follow me? Alright, now from here, now you have a quadratic, which you can factor on your own. So x minus 1 times, what's going to be 2x times something, right? So 2x times x. So what would give you negative 3 that would add up to be 5x? What do you guys think?
Minus 2x minus 1. Wait. Oh, yes. 2x minus 1 times x.
Good. 2x times x will give you the 2x squared. 2x times 3 gives you 6x. That's minus 1x, so that gives you the 5x, and that gives you the negative 3. So now you have successfully factored this out into linear factors, correct? And now you can find the zeros, right? So this would be f of x equals to all that, which means that your zeros are located at 1, 1/2, and negative 3. And from there, can you come up with a sketch on your own? Yes. Well, I didn't ask you to, but technically this is what we're using it for, okay? Now, let me ask you, if you wanted to continue, would you have still found the answers? Yes, because if you would have plugged in, you would have found out that at 1 we got 0, at 1/2 you would also get 0, and at negative 3 you would get 0. So you could have continued to use your calculator to figure all this out. And I don't mind if you do that. I don't. Okay? Now, here's one thing I want to bring up because I didn't actually put a problem like that. Sometimes it's going to happen that obviously you're looking at me and you're like, why would I want to do all that work on the left when I can just continue to plug it into the calculator and the calculator will do all the work? Well, here's what's going to happen. Sometimes I'm going to give you a polynomial that has, let's say, a degree of 5. So you're looking for at least 5 zeros, at most 5 zeros, correct? And then you're going to do all the possible rational zeros, and you're only going to find 3 of them. You don't know if you have a multiplicity of 2. You don't know that. But then you can use those 3 zeros to use synthetic division repeatedly until you get to a degree of 2. Correct? Because if we started with 5th power and you divide by 1 of the zeros, that brings you down to the 4th power, right? If you divide once again, that brings you down to the 3rd power. And then if you divide once again, that brings it out to a 2nd power, which you should be able to handle. At that point, a couple things could happen. It could actually factor out, and then you can find the rest of the zeros. Or some of the factors that you factor out would notice that they're repeated, so then you would have a multiplicity of 2 or whatever. Or the last thing that could happen, and that will be next lesson, is that it's something that it's not real. It is imaginary. And we'll talk about the imaginary number system, the complex numbers, next time. Okay? But in summary, you do not have to find all these values. You can use synthetic division, or if you want to continue to do it here, you can do it here. Just keep in mind that you won't always find all the real zeros using the rational zero test. Okay? Homework is page 124. That's that. And one last thing, I need you to flip the page. I want to add something. Yes. Something called the remainder theorem. Okay? And I'm really not teaching you anything. You've actually been doing this all day today. But I'm going to show you what it is and how you can use it. Okay? First of all, the remainder theorem, we're going to be using it to evaluate functions at given values. Okay? To evaluate functions at given values. Alright, so typically I would give you a problem and I would say, if you see this, what would you do? So if I give you a function and I say f of 2, what would you do? Typically, if I give you a function, you would just plug 2 in for the function, correct? Alright. Technically, that is the best way to do it, and I would honestly do that. If I'm not given an option, that's the way what I would do, right? I would go ahead and plug in that value. However, if I tell you to use the remainder theorem, so let me just find an example real quick. I want you to use the remainder theorem, and here's how it works. Okay, so here's a good one. Let's say that I give you the following function. F of x equals 3x to the 3rd power plus 8x squared plus 5x minus 7. Okay? Again, the easier way to do this would be, hey, I'm just going to plug in 2 for every x value and simplify and I'll get an answer, correct? On your quiz and your test, I'm going to say, use the remainder theorem. So what do you think, if I'm using something called the remainder theorem, what do you think is going to happen? Some division. Okay? So, you're going to use division, you're going to use synthetic division. You're going to divide by 2. Right? That's going to be your divisor. And on the inside, you're going to have 3, 8, 5, negative 7. Right? So, 3rd power, 2nd power, 1st power. So, I bring the 3 down. 3 times 2 is 6. 6 plus 8 is 14. Correct? 14 times 2 is 28. 28 plus 5 is 33. 33 times 2 is 66. Minus 7 is 59. You have a remainder. Do you guys agree? Your remainder is 59. So let me ask you, is 2 a 0 of the function? It's not. Do you guys agree? Because you had a remainder. So, but here's what this helped you out. Your answer is 59. If you plug that value in, I'll show you, I'll prove it to you. So if we say 2 store x, and I'm going to say 3x to the third power plus 8x squared plus 5x minus 7, you get 59.
Whoa. Oh my god.
Okay? The reason why division has been working for us this entire day today to help you factor things out is because of the remainder theorem. Except that to help us out factor things out, your remainder must be what? 0. But you can use the remainder theorem to evaluate a function at any given value. Okay? Your actual answer, right, is also, if I wanted to give a point, wouldn't it also be that I have in this graph there's a point 2 comma 59? Do you guys agree? Okay? So your answer would be this, but I just want you to realize that on this graph, somewhere along that graph, the point 2 comma 59 exists. Okay? Alright, questions about the remainder theorem? We're good? Alright, so that's all I got for you today. Quiz next time.